Welcome to the Deep Dive. Today, we're going to tackle something that might not sound super exciting at first.
Okay.
Software requirements engineering. But trust me, this is where the magic happens.
Yeah,
Even before a single line of code is written.
you got it. We're diving into a college lecture on the topic,
Okay.
which might sound a little dry at first,
Right.
but it's actually the foundation of every app, every website, every piece of tech you use.
Okay.
We're talking about the blueprints for how software gets made.
Okay, blueprints, that makes sense. But let's get real.
Sure.
How many times have you downloaded an app and thought, who designed this? This is so clunky.
Oh, all the time. And you know what?
Yeah.
There's a good chance that's a requirements problem.
Okay.
Think about it.
Mm-hmm.
A whopping 65% of software features are rarely or never used.
Wow.
That's a whole lot of wasted effort and resources.
65%? That's a crazy statistic.
It is.
I'm guessing that's why getting the requirements right from the start is so important.
Absolutely. And that's where requirements analysis comes in. Okay.
Think of it like this.
Okay.
You've got this big pile of raw data, user feedback, business goals, technical limitations.
Right.
It's messy.
Yeah.
It's confusing. It's basically a lump of coal. Requirements analysis is about refining that coal, chiseling away the unnecessary bits until you're left with a shiny diamond, the actual requirements that will guide the software development process.
Okay, I love that analogy. It's about turning chaos into clarity.
Yeah.
How do we actually do that? What's involved in this refining process?
Well, it starts with understanding the why behind user needs.
Okay.
It's not just about what they say they want. It's about digging deeper and figuring out what problem they're actually trying to solve.
Because sometimes what we think we want isn't actually what we need.
Exactly. Like those times you buy a kitchen gadget because it looks cool,
Oh, yeah.
but then it ends up gathering dust in a cupboard because it doesn't actually solve any of your cooking problems.
Oh, I'm totally guilty of that. So once we figured out the why behind user needs,
Right.
what's next? Well, then comes the detective work.
Mm-hmm.
You have to sift through all the information you've gathered and start identifying any conflicting or duplicate requirements. It's like putting together a puzzle, but sometimes the pieces don't quite fit.
Right.
Yeah,
Can you give us a real-world example of how that might play out?
absolutely. Imagine you're developing a secure building access system.
Okay.
You've got input from security personnel who want maximum security with fingerprint scanners and iris recognition.
Right.
Employees who want quick and easy access without jumping through hoops.
Yeah.
And fire safety officials who need to ensure emergency exits are accessible at all times.
Uh-huh.
How do you reconcile those potentially conflicting requirements?
That's a recipe for a requirements nightmare.
You got it. That's where negotiation and prioritization become crucial.
Oh, okay.
You have to figure out which requirements are non-negotiable, which ones can be compromised, and which ones might need to be postponed or even scrapped altogether.
So it's a balancing act, keeping everyone happy, while also making sure the system actually works and is secure.
Exactly. And it requires clear communication, a deep understanding of stakeholder needs, and sometimes some tough decision-making.
So we've gathered all this information.
Right.
We've refined it.
Yeah.
We've resolved the conflicts.
Uh-huh.
What happens next in this software building journey? How do we go from a list of requirements to an actual system?
That's where visual models come in. Think of them as blueprints for your software.
Mm-hmm.
They help you visualize the system, identify potential issues early on, and communicate effectively with everyone involved.
Okay, here's where it gets really interesting.
Yeah,
The lecture mentions a whole bunch of different models.
it does.
Can you give us a quick overview of some of the key ones?
Absolutely. There are models like context diagrams,
Okay.
which show how the new software fits into the existing environment,
Right.
or ecosystem maps, which map out all the different systems that interact with each other like a big interconnected web.
So we're starting to see the big picture here.
Exactly. But let's zoom in and focus on two essential models that really bring this to life: use case diagrams and data flow diagrams.
Okay, I'm all ears.
All right.
Let's start with use case diagrams.
Okay.
What are they all about?
A use case diagram is all about understanding how users interact with the system.
Okay.
It maps out the different actions a user can take and how the system responds.
Gotcha.
The lecture uses a restaurant analogy, which I love,
Yeah.
because everyone can relate to food.
I'm always up for a food analogy. Tell me more.
So imagine you're at a restaurant.
Okay.
You've got the customer who wants to order food, view the menu, and pay the bill.
Right.
Then you've got the waiter who takes orders, manages tables and processes payments.
Mm-hmm.
And of course, you have the chef who's busy in the kitchen preparing the food.
So those are all different actors in the system, right?
Exactly. The use case diagram would visually represent how these actors interact with the system. For example, the customer places an order with the waiter relays the order to the chef prepares the food, the waiter brings it to the customer, and then the customer pays the bill.
So we can see the flow of actions and interactions between the user and the system.
Yep.
And I'm guessing this helps developers design the software in a way that makes sense for the people actually using it.
You got it. It's all about putting the user at the center of the design process.
That makes a lot of sense.
Yeah.
Now, what about those data flow diagrams? What do they show us?
A data flow diagram, or DFD, visually represents the journey of data through a system.
Okay.
It's like tracing the path of a package as it moves through a delivery network.
Okay. I'm intrigued. Walk me through it.
Let's say you're buying something online.
Okay.
You enter your information, choose your items, put in your payment details.
Right.
All of that is data, and it's flowing through the system.
Uh.
The DFD would show how that data moves from one process to the next. It might go from the customer input to order verification, then to inventory check, then to payment processing, and finally to order fulfillment.
So it's like mapping out the data's journey through the system.
Yeah.
Showing all the different stages and transformations along the way.
Precisely. It helps developers understand how data is processed, stored, and retrieved within the system. It's crucial for building a system that's efficient, reliable, and secure.
This is all starting to make sense. We're seeing how these visual models can bring clarity to a potentially chaotic process.
Yeah.
But I'm curious, what about the people behind these systems?
All right.
We've talked about users.
Yeah.
But who else is involved in this whole requirements dance?
That's a great question, and it brings us to the next key piece of the puzzle.
Okay.
Stakeholders. Software is built for people by people.
Right.
And understanding the stakeholders, the users, developers, business owners, project managers,
Yeah.
and their goals is crucial for successful requirements analysis.
So we need to consider their perspectives, their priorities,
Yeah.
even their potential conflicts of interest.
Absolutely. And the lecture highlights a model that can help us do just that, the good old organization chart.
Okay, now I'm really curious. How does an organization chart help with software development?
Yeah.
I usually associate those with corporate hierarchies and who reports to whom.
Well, it's still about hierarchy.
Okay.
But in this context, it helps us understand the structure of the organization in relation to the software project.
Okay.
It shows the different roles and departments involved, who has the authority to make decisions, who will be using the software, who will be maintaining it.
I see. It's like a map of the human landscape of the project.
Exactly.
It helps us identify all the key stakeholders and understand their relationships to the project.
It's a valuable tool for ensuring that all the necessary voices are heard and that the software is designed to meet the needs of everyone involved, not just the users.
This is all fascinating stuff.
Yeah.
But it's also making me realize that in the real world, resources are limited.
Right.
We don't always have unlimited time, money, and people to build the perfect system.
Yeah.
So how do we deal with those constraints?
That's where prioritization and feasibility come into play.
Okay.
It's the art of balancing what's ideal with what's achievable.
So we can't always have everything we want.
Right.
There are trade-offs.
Unfortunately, yes. The lecture talks about technical, financial, and timeline feasibility. Sometimes a requirement might be technically possible, but way too expensive to implement.
Right.
Or it might take longer than the available time frame.
Right.
And sometimes we have to make the tough decision to postpone a requirement or even drop it altogether.
This is starting to sound a lot like Project Management 101.
It is. Requirements analysis is closely tied to project management.
Right.
You have to constantly juggle priorities, manage expectations, and make sure the project stays on track and within budget.
This has been an incredible deep dive so far. We've gone from raw information to refined requirements. We've explored visual models and considered the human element.
It's a lot.
It's amazing to see how much goes into building software before a single line of code is even written.
It's a complex process.
Yeah.
But it's essential for creating software that actually works and meets the needs of its users while also staying within the realm of what's possible.
And I'm starting to think that this knowledge isn't just for software developers.
Right.
Anyone who uses technology can benefit from understanding these concepts.
I completely agree. It gives you a whole new appreciation for the complexity behind the apps and systems we use every day.
Yeah.
And it helps you understand why sometimes things don't work exactly as you'd expect. It's all about those behind-the-scenes decisions and compromises.
This has been a fantastic deep dive into the world of software requirements engineering. We've unpacked a lot, but there's still much more to explore.
There is.
So stay tuned for part 2.
We'll be back after a short break to delve even deeper into the fascinating world of software models and how they translate into real-world applications.
Welcome back to the deep dive. Before we jumped into the break, we were talking about the importance of understanding stakeholders and their roles in software development.
It's like putting together a puzzle, right? You've got all these different pieces, the users, the developers, the business owners.
Yeah.
And they all need to fit together to create a successful software system.
And we even talked about how something as simple as an organization chart can be surprisingly useful in this process.
It's all about seeing the big picture, isn't it? Understanding not just the what of the software, but the who and the why behind it.
Right.
And speaking of the big picture, we were just starting to explore those fascinating visual models.
Right. Those models that are like blueprints for software.
Yeah.
They help us visualize the system,
Yeah.
identify potential issues early on, and communicate effectively with everyone involved.
Exactly. And remember we talked about use case diagrams,
Yes.
which map out how users interact with the system.
Yeah.
Kind of like that restaurant example with the customer, the waiter, and the chef. And we also touch upon data flow diagrams,
Right.
which trace the journey of data through the system, like that online order placement system, where data flows from customer input all the way to order fulfillment.
Right. Now, the lecture mentioned a whole bunch of other models.
It did.
Can we dive into a few more? I'm really curious to see how these different models help us understand the software development process from different angles.
Absolutely. Let's unpack a few more of these modeling tools.
Okay.
The lecture mentioned something called a context diagram.
Okay. What exactly is the context in this case?
Well, imagine you're building a brand new house.
Okay.
The context diagram is like a site plan. It shows you the boundaries of the property where the house sits in relation to the surrounding environment and the connections to external utilities like water, electricity, and sewage.
So it's about understanding how the system we're building fits into the bigger picture,
Right.
like how it connects to other systems or interacts with the outside world.
Exactly. In software terms, the house is your new system, and the environment could include existing systems,
Right.
users' databases, external services, anything that interacts with your software.
So it helps define the scope of the project and shows us where the boundaries are.
Yeah.
What kind of information would you typically include in a context diagram?
You would typically represent the system you're building as a central box,
Okay.
and then use arrows to show the flow of information between the system and external entities. For example, if you were building a new e-commerce website,
Right.
your context diagram might show connections to a payment processing system, a shipping service, a customer database, and so on.
Okay.
It gives everyone a clear visual representation of what's included in the project and what's outside of its scope.
That makes a lot of sense.
Yeah.
It's like drawing a line in the sand and saying, this is what we're responsible for and this is what we're not.
Okay, now the lecture also mentions something called an ecosystem map.
Right.
How is that different from a context diagram? Think of the ecosystem map as zooming out even further.
Wow.
Instead of just showing your house and the immediate surroundings,
Yeah.
it shows the entire neighborhood.
Okay.
It helps you understand the complex web of relationships between systems and identify potential dependencies or conflicts.
So instead of just focusing on one system,
Right.
it shows how that system interacts with other systems in its environment.
Exactly.
Kind of like a map of the software landscape.
Exactly. Let's stick with that e-commerce website example.
Okay.
The ecosystem map might show how the website connects to other systems like inventory management, marketing automation, customer support, social media platforms,
Wow.
even competitor websites.
Wow. That's a lot of connections. It's like a whole ecosystem of software working together.
It is. And understanding those connections is crucial for successful system design and implementation.
Right.
You need to know how changes in one system might affect others. For example, if the inventory management system goes down,
Yeah.
how will that impact orders placed on the website?
Right. So the ecosystem map helps us anticipate potential problems and plan for them.
Yeah.
It also gives us a better understanding of how our system fits into the bigger picture.
Right.
And how it might impact other systems.
Precisely. It's about seeing the interconnectedness of everything and designing systems that work well together.
These models are fascinating. It's like we're peeling back the layers of complexity and seeing the inner workings of software development.
That's exactly what we're doing.
Yeah.
And there are even more models we could explore,
Oh, wow.
each providing a unique perspective on the system. We have state diagrams that show how the system behaves under different conditions.
Right.
Sequence diagrams that map out the order of events in a particular interaction.
Right.
It's a whole toolbox of visual aids for understanding complex systems.
Oh, I'm eager to learn more.
Sure.
But I'm also starting to wonder, how do you actually create these models? Is it all just boxes and arrows on a whiteboard?
It can start that way. Brainstorming sessions with whiteboards and sticky notes are definitely part of the process.
Yeah.
But there are also specialized tools and software that help you create, manage, and share these models in a more structured and collaborative way.
A blend of creativity and technical expertise.
Absolutely. You need to be able to think abstractly and visualize complex relationships.
Right.
But you also need to understand the technical aspects of the system and the tools available to represent them effectively.
It sounds like a challenging but rewarding field.
It is.
You get to be both creative and analytical.
And it's constantly evolving as new technologies and approaches emerge.
Right.
The tools we use today are much more sophisticated than they were even a few years ago, and there's always something new to learn.
I can imagine. So we've talked about the what and the how of these models, but I'm curious about the why.
Sure.
Why are they so important in the software development process?
Yeah.
What are the real benefits of using these models?
That's a great question. These models aren't just for show. Right. They serve a very practical purpose.
Okay.
First and foremost, they help to clarify requirements.
Okay.
By visually representing the system, you can identify ambiguities, inconsistencies, and potential conflicts early on before they become costly problems down the line.
So it's like catching errors in the blueprint before you start building the house.
Exactly.
Yeah.
It's much easier and cheaper to fix a mistake on paper than it is to tear down a wall and rebuild it.
Right.
Models also help to improve communication between stakeholders.
Okay.
They provide a shared language and a common understanding of the system, which can prevent misunderstandings and costly rework.
I can see how that would be especially important in large projects with lots of people involved.
Yeah.
Everything needs to be on the same page.
Absolutely. Models can also help to reduce risk and improve the overall quality of the software. By identifying potential issues early on, you can mitigate risks and design more robust and reliable systems. And by documenting the system in a clear and concise way, you make it easier to maintain and update the software in the future.
It sounds like these models are essential for successful software development.
They are.
They help to ensure that the software is well designed, meets the needs of its users, and is built to last.
Exactly. They are powerful tools that can make the software development process smoother, more efficient, and ultimately more successful.
This has been a fantastic exploration of software models. We've seen how they help us understand the system from different angles, communicate effectively, and mitigate risks.
Yeah.
Like we've been given a secret decoder ring for the world of software development.
I love that analogy. And the best part is this knowledge isn't just for developers or technical experts.
Right.
Anyone who uses technology can benefit from understanding how these models work and why they're important.
I completely agree. It gives you a whole new level of appreciation for the thought and planning that goes into creating the software we use every day.
Exactly. And it can even empower you to be a more informed and engaged user, providing valuable feedback and contributing to the development of better software.
Right.
But that's a topic for another deep dive.
Absolutely. This has been an incredible journey so far.
Yeah, it has.
We've gone from the why of requirements to the how of modeling. And we've even seen how these models can be used to manage complexity and improve communication.
Right.
But there's still one more piece of the puzzle to explore.
Okay.
How do these models translate into real-world software?
Yeah.
How do we go from boxes and arrows on a diagram to lines of code? Stay tuned for part 3, where we'll unpack that very question and bring this deep dive full circle. Welcome back to the Deep Dive. We've been on quite a journey exploring the world of software requirements engineering.
Yeah, we've gone from those initial light bulb moments, those moments of inspiration,
Right.
through that messy but crucial phase of gathering and refining requirements. And we've even explored those visual models that are like blueprints for software.
And what's really fascinating to me is how interconnected everything is.
Is.
Requirements aren't just static documents.
No.
They're constantly evolving based on user feedback, business goals, even the organizational structure of the company building the software.
That's like a dance, isn't it? A constant back and forth between what's ideal, what's feasible, and what ultimately delivers value to the users.
And speaking of that dance, we've explored some pretty cool moves.
We have.
Context diagrams, ecosystem maps, use case diagrams, data flow diagrams.
Yeah, whole bunch.
It's like a whole toolkit for understanding complex systems.
Each model gives us a different lens to view the system through helping us identify potential issues, clarify communication, and ensure everyone's on the same page.
But I'm curious, how do these models actually translate into real-world software?
Yeah.
How do we go from boxes and arrows on a diagram to lines of code that make the magic happen?
That's where the developers come in. They take those blueprints, those models we've been talking about,
Right.
and use them as guides to build the actual software. Think of the models as a recipe, and the developers are the chefs bringing that recipe to life.
So the models aren't just for show, they're actually used to build the software.
Absolutely. They provide a shared understanding of what needs to be built, how different components should interact, and how data should flow through the system.
Can you give us a specific example of how a model might inform the development process?
Sure, let's go back to that restaurant analogy we talked about earlier.
Yeah.
Remember we had the customer, the waiter, and the chef, each with their own set of actions and interactions with the system?
Right, the customer places the order, the waiter takes it to the kitchen, the chef prepares the food.
Yeah,
It's all mapped out in the use case diagram.
exactly. Now let's say the use case diagram specifies that the customer can place an order online view, the menu, track their order status, and provide feedback.
Okay.
Those actions translate directly into features that the developers need to build.
So the developers would create a user interface for online ordering a database to store menu items, a system to track order status, and so on.
Precisely. And they would use the use case diagram as a guide to ensure they're building the right features and functionalities to support those user interactions. It's like having a checklist to make sure nothing gets missed.
That makes a lot of sense. It's like translating a design concept into a working product step by step.
Exactly. And it's not just use case diagrams.
Right.
Other models, like data flow diagrams, can inform how data is structured, stored, and processed within the system.
Okay.
They can help developers choose the right databases, design efficient algorithms, and ensure data security.
It's fascinating to see how these abstract models, these boxes and arrows, translate into tangible features that we use every day.
It's like watching an idea come to life.
Yeah.
And the more detailed and accurate the models are, the smoother the development process will be.
Right.
It's all about reducing ambiguity and ensuring everyone's on the same page.
But I imagine it's not always a perfect translation.
Right.
What happens when things don't go according to plan? What if new challenges emerge during development?
That's where communication and collaboration become even more important.
Oh, well.
Throughout the development process, there's constant feedback and iteration. Developers might discover new constraints, users might request changes,
Right.
or business requirements might evolve based on market conditions.
So it's not a one-way street. The models aren't set in stone.
Absolutely not. They're living documents that adapt to the changing needs of the project. It's a continuous process of refinement and adjustment.
This has been an eye-opening deep dive. We've explored the hidden world of software requirements engineering, from the initial gathering of information to the creation of those visual models and their translation into real-world software.
It's a reminder that behind every app, every website, every piece of technology we use,
Yeah.
there's a whole team of people who had to figure out what it should do, how it should work, and who it should serve.
And sometimes they get it right, creating something that seamlessly meets our needs and makes our lives easier.
But even when they don't, understanding the process helps us see the challenges and complexities involved. It's a reminder that software development is a human endeavor with all its inherent complexities and trade-offs.
So next time you use an app or a website, take a moment to appreciate the hidden world of requirements engineering that made it possible.
Yeah.
All those steps, all those decisions, all those people working together to bring a digital idea to life.
It's quite amazing when you think about it. And it's a process that's constantly evolving as new technologies emerge and our needs as users continue to change.
Well, on that note, we've reached the end of our deep dive into software requirements engineering. It's been a fascinating journey.
Thanks for joining us. We hope you've gained a new appreciation for the complexity and creativity that goes into building the software that powers our world.
And remember, the next time you encounter a clunky app or a confusing website,
Yeah.
Think about those requirements. Maybe they weren't quite as clear as they could have been.
Or maybe there were some tough trade-offs that had to be made along the way. It's a complex process, but understanding it can make us all more informed and empowered users.
Thanks for listening to The Deep Dive, and keep exploring.